All right, so today we're continuing with vectors. The first thing we're going to do today is look at application problems that involve pushing something up an incline. So I think the diagram's the key, like always. So we want to find the force required to keep a 3,000-pound car parked on a hill that makes an angle of 15 degrees with the horizontal. We'll round our answer to the nearest hundredth. All right, so we'll start with our picture, something that's on an incline. We have a 300-pound car parked on this hill. I'm sorry, 3,000-pound car parked on this hill. Remember that weight is, the result of gravity pulling on our mass, and gravity always pulls straight down. So the vector representing the weight of this car should be straight down. And since that's perfectly vertical and the incline that I drew in the bottom is perfectly horizontal, that means that we have a right angle right here. We're looking to find the force required to keep this thing parked on the hill. Well, the force is the vector that is parallel to our incline pushing on our object. Vectors can be moved anywhere they want in the plane as long as you keep their magnitude and direction the same. So I can pick up this red vector and move it, and where we want to move it is down here. Oh, I didn't label my blue vector. I should do that, 3,000. And then the last thing we want to do is we want to draw in a vector that starts the same place as our blue vector, but is actually perpendicular to our incline. Okay. Questions on the diagram? Well, we need to get some more information to solve for x, and really all these diagrams are exactly the same. We're going to use the same two tricks over and over again. If we take a look at our ramp and this vector here, those two vectors are parallel to each other. If we then take a look at this green vector that we drew in, we end up with two parallel lines cut by a transversal. When that happens, we know that alternate interior angles are congruent. So this right angle that we have right here, we're going to end up alternate interior angles making this a right angle as well. Questions at all on that? All right, well, still looking at those two parallel lines, we have another vector that can be seen as a transversal, this blue one here. And again, alternate interior angles are congruent, which means that this angle and this angle would be the same. Now, we don't know what they are, but if we shift our attention to this right triangle versus this right triangle here, they both have a 90-degree angle. This angle, I guess I should have named it, alpha, is the same for both of them. So since two of the angles inside the two triangles have the same measure, that forces the third one to also have the same measure. So that means that this right here is 15 degrees. Questions so far? All right, well, I'm going to break out that yellow triangle. I think I'm going to stand it up right too. Since we're dealing with a right triangle, SOHCAHTOA applies. And from our 15-degree angle, we have the opposite side and the hypotenuse. So that's sine. We get that sine of 15 degrees is equal to x over 3,000, making x equal to 3,000 times sine of 150. And then we're just going to plug that into our calculator and round to the nearest hundredth. And I do not have an answer for that.
Sine of 150 or sine of 15?
Oh, absolutely sine of 15, thanks. I guess I took my degree symbol as a 0.
I got 776.46.
Anybody else get that?
That's what I got too.
Great, and our force unit is pounds. Great. Questions at all? They're really all exactly the same, which kills me because I struggled so much with these as a student, and now I see, wow, they are like exactly the same. You get your diagram set up. You're going to do two parallel lines cut by a transversal twice to get your angle measures, and then we're just using SOHCAHTOA. Let's try another one. A force of 16 pounds is required to hold a 40-pound lawnmower on an incline. We want to know what angle does the incline make with the horizontal. We'll round our answer to the nearest hundredth. Now, starting with our diagram. That's the worst. Don't know the angle in question. Here's my, oh, it's a lawnmower. I was making something else. Yeah. The lawnmower is a 40 pounds, so that's going to be a vector going straight down since gravity goes straight down. Since it's perfectly vertical and our horizontal, the bottom of our incline triangle is perfectly horizontal, that means that we have a right angle right here. A force of 16 pounds is required to hold it in place, but as we said before, a vector can be moved around the plane as long as we keep its magnitude and direction the same. So I'm going to move this down here. And then we are going to drop a vector that's perpendicular from our incline right here. And now we're ready to use our parallel lines and our transversals. So 2 parallel lines. The first transversal it's cut by is this green one here. Alternate interior angles are congruent, making this angle right here 90 degrees. Switching to look at our blue vector. Okay, so now looking at this blue vector here, again, we have alternate interior angles that are congruent. So these two angles here and here have to be the same. Looking at this right triangle versus this right triangle, we notice that they both have a right angle and an angle alpha, so that means that their third angle has to be the same as well. So this has to be angle theta up here. And I'm going to break out that yellow triangle. This angle theta at the top is equal to the angle of inclination, and that's what we're trying to find. So from our theta, that is the opposite side and the hypotenuse. So that's going to be sine again. Sine of theta is 16 over 40, making theta sine inverse of 16 over 40. And again, we're rounding to the nearest hundredth.
I got 23.58 degrees.
Anybody else get that?
That's what I got too.
Great. All right, so there we go. Every single one of these ones where something's being held up a ramp or pushed up a ramp follows this exact same sequence of events. Questions at all? Okay, I think we got just one more application here. Kind of didn't fall into any category. It's just a bearing problem. So a luxury liner leaves port on a bearing of 110 degrees and travels 8.8 miles. It then turns due west and travels 2.4 miles. How far is the liner from port and what is its bearing from port? We'll round our answer to the nearest hundredth. All right, so we're starting with a diagram. All right, so this liner is leaving port on a bearing of 110 degrees. We know when we're given a bearing that's a single number that we're starting from a due north line and then rotating clockwise that many degrees. Maybe something like this, 110. All right, and they went 8.8 miles. Then it turns due west and travels 2.4 miles. So here's my due north line again. And traveling due west. .4 miles. And then we want to find how far is the liner from port. So we're looking for that right there. Okay, well, that's all the information they give us. That is certainly not enough to start this problem because we don't have any angles inside the triangle. So what can we do to get some angles inside the triangle? Ideas? Anything? Now, remember, this big angle here is going to be 90 because we have a due north line and a due west line.
Well, since both of the bearing lines are parallel,
Yeah,
the 8.8 miles line, I forget the term.
transversal.
Yes, and which would make the angle that is the opposite also 110, which means since it's on a straight line, the angle on the opposite side would be 70 degrees.
I like everything you had to say. Everybody see that? Any questions that so far? All right, well, great. I'm glad we got that information, but how does that help us get an interior angle to our triangle?
Uh, wouldn't that other part be 20 degrees then to get to 90?
Right? So
Like
since
that, yeah.
two different ways we can think about it. This little bit right here, you can either take 110 degrees minus 90 or 90 minus 70. This is going to give you 20 degrees. And now I'm going to break out this triangle. So that's 8.8, 20 degrees, 2.4, and we're looking for X. This is not a right triangle, so SOHCAHTOA will not apply. What are we going to have to use instead?
Law of cosines.
We're going to have to use law of cosines because we do not have a known bear. All right, so that's going to be x squared equals 8.8 squared plus 2.4 squared minus 2 times 8.8 times 2.4 times cosine of 20 degrees. And as always, I definitely just put that whole thing in my calculator with the square root in it. Okay, and while you guys are popping that in your calculator, I'm gonna go get my kid on his Zoom meeting with his teacher. I'll be back. Okay, so what do we get for a decimal rounded to the nearest hundredth?
6.60.
I'm sorry, say that again.
6.60.
I'll buy that. All right, there we go. Questions at all? Oh, jeez. Anybody? Questions? All right, dot product is next. The dot product of two vectors is the sum of the product of their first components and their second components. So if we want to dot u and v, u being equal to ab, v being equal to cd, our dot product is a times c plus b times d. Please note that the dot product is a real number, not a vector. Dot products are used to determine the angle between two vectors, derive geometric theorems, and solve physics problems. So let's start by just practicing finding the dot product. It's going to be -3 times 7 plus 8 times -5. -61. Anytime I'm given a vector in this AI plus BJ form, the first thing I like to do is just get it out. I prefer to have it in the angle brackets. This is 2, 4, and this is 0, -1. So then our dot product, 2 times 0 plus 4 times -1. It's going to be 0 minus 4, which is -4. Questions on finding the dot product? So we've got some properties of dot products. It basically follows all of our properties of real numbers, of properties of vectors. It's true that dot product is commutative. That's our property number 1. Number 2 says that it is distributive. Number 3 also says dot product is distributive. Number 4 shows that dot product is associative. Number 5 says if you dot any vector with the 0 vector, you get 0, which makes sense since the components of the 0 vector are both 0. And if you dot a vector with itself, you get the magnitude of the vector squared. I think that, to me, this is the only one that seems like something new or something that doesn't come natural to my thought. All right, so we've got 3 vectors here. We just want to perform some operations. So this first part here, yeah, it is true that dot product is distributive, but personally, I wouldn't do it. I would just find the difference between the 2 vectors and then dot it once rather than dotting things twice. Starting with v minus w, that's just where we are subtracting our first components and our second components. And when it's subtraction, I always like to distribute the negative and then make it addition. So this is going to be 8, -8. And I'm going to take my vector u and dot it with that. So -2 times 8 plus 1 times -8. negative 24. Questions at all? All right, next up, we want to dot vector u with 3 times vector w. In this case, I don't know, it doesn't really matter to me whether you do the dot product first and then multiply by the 3, or multiply one of the vectors by 3 and then do the dot product. I think they're about equal, so I don't really have a recommendation for that. I think I'll just multiply 3w and then dot it. So vector u is negative 2, 1. 3 times vector w is going to be negative 1536. So we get negative 2 times negative 15 plus 1 times 36. 30 plus 36, we get 66. Questions at all? The dot product between two vectors can be positive, negative, or 0. A geometric interpretation of the dot product explains when each of these cases occur. This interpretation involves the angle between the two vectors. So if we consider vectors u equal to AB and v equal to CD, the angle theta between vector u and vector v is defined to be the angle having the two vectors as its sides, for which theta is in between 0 and 180. So you're just taking the, well, I don't want to say acute, but less than 180 degree angle. So like if the other vector was down here instead, our angle theta would be over here, because if we went the other way, we'd be over 180 degrees. So if theta is the angle between these vectors, then u dot v is equal to the magnitude of u times the magnitude of v times cosine of theta. Frequently, what we're trying to solve for, though, is theta, so we often just rearrange this formula and remember it instead as cosine of theta equals u dot v over the magnitude of u times the magnitude of v. So let's find the angle between each pair of vectors. The formula we're going to use, cosine of theta equals u dot v divided by the magnitude of u times the magnitude of v. I need to find 3 things. I need to find u dot v, I need to find the magnitude of each of the vectors, and then I can plug those numbers into our formula. So starting with u dot v, 1 times 1 plus 7 times 1, that's going to be 8. The magnitude of u, this is where we're using the square root of a squared plus b squared. So I guess I just got to name them. So that's going to be the square root of 59. I wouldn't even waste my time simplifying that to 5 square root of 2, because I'm going to be multiplying it by something else and just shoving it in my calculator, so I wouldn't spend the time. And then we need the magnitude of our vector v. That's going to be the square root of 1 squared plus 1 squared. You got to get out of here with that. It's way too loud. So that's giving us the square root of 2. And now that we have all our numbers, we're ready to plug it in. Cosine of theta is equal to 8 over the square root of 50 times the square root of 2. So maybe I'd clean up this bottom a little bit, right? We got the square root of 100, which is just 10. So cosine of theta is equal to 8/10, therefore theta is cosine inverse of 8/10. So we'll just pop this in our calculator and round to the nearest hundredth. Making sure you're in degree mode. So what do we get? Anybody get an answer?
36.87.
All right, thank you. All right. All right, why don't you guys try the next one? So I got 9 for my dot product, 13 for the magnitude of u, and square root of 13 for the magnitude of v. We'll plug it into our formula. We get the theta equals cosine inverse of 9/13 square root of 13. Anybody get anything different? Well, once we plug it into our calculator, what do we get?
78.93.
There we go. Questions at all? All right, last thing. Two vectors are parallel when the angle between the vectors is either 0 degrees or 180 degrees. If that angle is 0 degrees, then we have the exact same vector. And if that angle between them is 180 degrees, then we have the opposite vector. If u dot v equals 0 for two non-zero vectors, then cosine of theta equals 0, which means that theta is equal to 90 degrees. Thus, u and v would be perpendicular, but in this context, we use the word orthogonal instead of the word perpendicular. We do that anytime we're talking about vectors, word orthogonal. So we want to determine whether these two vectors, v and w, are orthogonal. The only way to do that here is to find the dot product and see if it's equal to 0. Because if it is, well then great, that forces theta to be 90 degrees. I'm going to write my angle brackets first. And then we'll dot this. And we do in fact get 0, so v and w are orthogonal. And there we go. Questions at all? So that actually ends unit 3 for us. So that means it's test time. I want to pull up our calendar and take a look at our revised calendar together. Because I think we're actually a day ahead. Yeah, so we're an entire day ahead. If you look at that. So I know that this class sometimes likes to get ahead and then skip a Friday. If you guys want to do that, we can certainly do that. What is the will of the group?
I think that would be a good idea. That would be nice to have a
Yeah.
Friday off.
Okay, so that'll be the plan. I mean, I still got to write this test. I haven't even started. I got to write this test. All right, so my plan will be on Monday, we will start conic sections and we'll discuss the ellipse. Then that's going to be the last day of class then next week. We won't have class the rest of the week because for Wednesday, we're going to have a test. And then Friday, since we're ahead, we won't need to hold class. What I'm going to do for the test, though, is that I think I'm going to give a 48-hour window. I'm going to create something on my math lab. I'll give you a 48-hour window, no partial credit. And I'll give you 2 attempts. I'll make it start at 12 a.m. on Wednesday and then be due at 11:59 on Thursday.
And is that through the My Math Lab?
Yeah, which I know has been like shoddy here lately, so relax. You know that if it's not working, that I'll be like, don't worry, I'll push the due date or whatever. So don't worry about that. But
Okay.
that's the best thing I got right now. Like,
Yeah.
I mean, other than just giving you, I guess, the paper test and then having you do it and then resubmit to me, but man, I'd have to be ruthless on my grading since it's take home. So we're gonna try the My Math Lab thing instead. Anybody questions
Can we
about
still
that?
do the bonus quizzes then for the extra
Yeah, I
5
left
points?
them up there, even though they're take home now. God, that just means you all should get A's, right? Wrapping up the end of the semester, if 3 out of your 5 tests, and the finals double, so we're really looking at 4 out of 6 tests are going to be take home. There is no reason you should not be crushing that and getting all A's here and doing that little bonus. Plus, it's not like you're going out and hanging out with your friends, so you got nothing else to do but sit home and work on this math. I know, Jason, I know you're at work. I know, Destiny, and I know you're at work too.
So is that final also going to be on My Math Lab then?
Yes, and in fact, at the math department meeting, no. Well, I did have a math department meeting on Wednesday, but I also talked with the dean of math yesterday, and she says that we should all count on remote instruction through the end of the summer.
Wow.
So those of you who are going to register for summer face-to-face classes, it's going to be just like this. That's what they're already anticipating. So
Okay.
it is what it is. I don't know. I don't hate it, but I guess I'm the teacher, not the student. So I'd be curious at the end of the semester to get feedback from good students like you just across the board, what your experience was like, because I feel like this is virtual plus.
I can't tell you how much gas money I've been saving.
For real.
Yeah.
I wonder about students who shy away from virtual because they think they would just be on their own. And if this would be something that would really be something that students would like because they can do it from the comfort of their own home, but they can stop their instructor in the middle of an example and say, hey, I had a question about this and stuff. So
Yeah.
I'm curious. I want to do like a survey at the end. I'm curious what students thought of the remote instruction.
I'd be all for it.
Yeah. Well, I'd be happy if you guys feel that way to give you some email addresses to email in a month to say we would enjoy this. So, all right, anybody, anything else? So since we're moving up the test, that means that we're moving up the other due dates too, right? Homework and the Dropbox quiz.
So when is the next Dropbox quiz is due?
I think it's scheduled to be due on Thursday at midnight. I'm gonna make it due Wednesday at midnight. So I think I'm just gonna back it up one day. Here, let me get online and look and see right where it is.
So then would the homework be Wednesday?
Yeah, I'm
as
gonna
well?
back it up one day because I'm hoping that you have that stuff completed before you take the exam because I'm trying
Yeah.
to prepare you for the test. So that's my
Okay.
thought process. And since I'm gonna let the test run until Thursday at midnight, I'll make all this stuff due Wednesday at midnight.
Okay.
That's
So
my
then the bonus points quiz would then be due Wednesday at midnight also?
yep. I'm gonna
Okay.
change them all. I'm doing that right now, so I don't forget.
All right.
Anybody else? Anything?
So that test is opening up on Tuesday then? You said
Well,
48
I mean,
hours?
I guess technically Tuesday at midnight.
It would, okay.
Like, you know what I mean?
Yeah, okay.
And like I said, I'm going
And-
to give 2 attempts. I would definitely take both attempts, but it's not going to be the same test twice. We can pool questions. So you randomly get 1 of 5, plus then they're algorithmically generated and stuff like that. So also, you will only be able to review the exam immediately after submission. All right, so don't click out of whatever your score is super fast because that's the only time you're going to be able to see if you got which ones you got wrong and what the correct answers are. So be cautious on that.
All right.
Anybody else? All right, well, have a great weekend. If you need anything, you know how to get a hold of me.
All
See ya.
right.
Thanks.
Bye.
See ya.
See ya.